Okay, so here we are in the lab again. Last time we we got into starting our design in Fusion 360. So I've got a schematic completed, and I got most of the PCB laid out, except I'm going to tie in the last of the grounds using the backplane, and I'm going to show you guys that. I saved that to show you, because you don't have to connect your VSSs or your ground. You don't have to connect them together on your PCB. You can just wait until the end, and then you just tie those together with your ground planes. And I put a ground plane on the top and the bottom. For a two-layer board, that's kind of the best to keep the noise down from between digital and analog and just power supply noise and stuff. So yeah, let me show you that first, and then we'll get into component selection, how I did that, and that won't take long, and then we'll go through the schematic a little bit so you know what we're doing. Oh, and also, if you just want to build this board as standalone, you can take all the interface stuff from MainBrain that's on the left-hand side, and you can just remove all that, and you don't have to supply your own power, 3.3 volt power. But yeah, you can just use that as a standalone board, and it'll work the same. You can program it and everything. You just have to supply your own power. Okay, all right, so let me show you doing the backplane in Fusion 360. All right, so here's the PCB I got. So I should have everything connected. So we'll do the backplane. So the first thing you want to do is select polygon, because you're gonna cover the whole board, and then it's automatically gonna go around everything that's not connected, and it'll connect all the grounds together. Okay, so you've got your polygon. You want to select square corners, huh? And what's the fill style here? Just hatched and solid. So we want to do solid. And so you just select a corner of the board, and you just move it over to the next corner, get it lined up, click, and it doesn't have to be perfect. And click, and then click again, and it'll ask you to name it. So we'll call it VSS. So it'll connect all the VSSs together, and there you go. And that's the way you do the back plane, the ground plane. So then I want to do, that's the top, I want to do the bottom, so you just select the bottom. And same thing, polygon, click in the corner, line it up, bring it over, click, click, click for the corner one to finish, and there you go. Alright, so we're done there. So that's our back plane, and we'll go back to the front, just so, or to the top. So that's our board. We'll save it up here. Alright, so now that should be pretty much everything, except it has to get checked to make sure there's no problems. And I do see one little air wire over here that we're going to have to fix, but the design, when we do the design rule check, we'll do that. So, but that's what I wanted to show you right there. So then we'll go to the next thing. All right, so that was the ground plane and tying in VSS, all the VSSs together. So then let's go over the schematic, because that's kind of where you start. So yeah, we'll start it on the schematic. I'll describe some of the components, how it works and stuff, and the general idea. And then I'll show you how I selected the components, and we'll go from there. There's our schematic. All right, and I want to show one thing here first. I don't have it all straightened out totally, but I like to make a couple new folders in my project and keep the models in one and parts in the other, because it's kind of hard to tell it apart sometimes. So I like to do that. I don't quite have it all sorted out yet, but I'll try to get that done. And then so when I upload everything to the website, the public folder, then everything will be squared away. But I don't know how neat I can make it right now. But anyway, here is the schematic. And I'm not going to get into any big details right now, because we're going to get into crazy detail later. So this is going to be, I haven't tested this yet, so we're going to have to do that. But this is the main brain interface. And all the I/O cards in the project are going to have this kind of a universal. It's the bus interface, bus arbitration, and to select different boards through some address select lines on main brain. And we got an oscillator here. This is the microcontroller. And we got ICSP connector where we program it. We have the reset supervisor that holds the reset signal low until the power stabilizes, and a jumper to be able to remove it from the reset signal so that it doesn't interfere with the ICSP. It usually works fine with it, but that's an option in case there are problems programming it. And so now for the main meat of the project here. This is 8 LEDs used for status and debug port. Then we have 2 NPN transistors that basically drive the signal, the digital to analog out of the microcontroller. And so we can select, we have a digital potentiometer here, and so that's hooked to the emitter, so we can change the voltage from 3.3 volts peak downward. I don't know how far it's going to go. We're going to find that out. It might not even work the first time. We're going to have to debug it. And that drives the outputs here, the analog outs. And then we have an op-amp in. So it's basically an op-amp inside the microcontroller. So we have that, the 2 inputs here that we can put in, and I forget how I have it, but we're going to work on that too. I think it goes to the ADC input, one of the ADC inputs. So we're going to have the op amp, like we could do an instrumentation amp or a digital voltmeter or something like that. And then we have 4 MOSFETs here that are just turn the MOSFETs on and off so that we can switch an external signal. Okay. And then we have a PWM out, so we can do a PWM signal, and it's a pretty sophisticated PWM we can do. We can make some we can't quite do composite video speed, but we can do some comparable signals. And then we have some universal IOs. They can be like analog in, digital out, analog out. And we can do some different things with it inside the microcontroller. So I think that should be able to we should be able to do a lot of signal control with that, and we might add and we might change. That's the whole point of the project. And so this is version 1, okay? So then, since the last part, I added some stuff here on the PCB. So we got our name of our board here, and I labeled what the outputs are and stuff like that, so we know what's going on more. And I think I'm going to add like a pin 1 thing. We got to have a pin 1 so you don't put it on backwards. And I think that's pretty good. And then if we look at our 3D image, this is what it's going to look like. I don't know why the green board is like brighter on this version, on this one for some reason. So we're going to put a jumper on here to select the board address. We're going to put a jumper on here for normal operation for the reset. This is where we put the ICSP to program the microcontroller. Then we got the outputs we just talked about. And our digital potentiometer here, some MOSFETs, 2 NPN transistors. On the back, we have our bidirectional, our bus transceiver, and this is our reset supervisor, and that should do it. That's pretty much it. Okay, so we're moving along pretty good. We got our schematic done, we got our PCB done, we got a 3D representation of what it's supposed to look like. Things are labeled. There might be a couple little things left to do, but that's up to you if you want to do finer detail. But once you reach this point, then you have to do a design rules check. Okay, so now that puts us at a point where the design rules determine the spacing between the traces, the minimum thickness a trace can be, the minimum clearance between components, a whole list of things like that. And the defaults usually work, but on this one, I have the vias for the traces. I have them at 0.2 for the drill size for the hole, plated through hole inside, and the default Fusion it'll flag that as a problem, so you have to change the design rules in there. We'll do that and make it 0.2 millimeter. But when you do that, you have to make sure that the manufacturer for your PCB that you are going to submit your Gerbers to can drill a hole that small. Most of them can, but you have to check that. But if you go to their website, they will have a parameters list of what they can provide. And you have to make sure that you don't design outside their limits, because when you submit it, they're going to reject it, and then you'll have to change it and resubmit it. And you probably will. The first time I did it, I didn't know a lot of things, so I had to resubmit it for like 5 times before I actually got it accepted and had it made. But once you know all those little things, then you can just submit it and they accept it, and you get your PCB in a few days and you're a happy camper. So let's go to PCBWay's website. That's who I use. And I'll use that as an example and show you real quick how to check the design parameters. All right, we're going to go to our browser here, and we're going to go to PCBWay.com. All right, and then so you want to check you might want to just get familiar with this and look around and stuff. We're going to do the PCB prototype. It's cheap. It's like 15 bucks a board, unless they change the price since I've been there last. And then you can get a quote before you even order anything, tell you how much it is. But right now we're interested in the product capabilities. So we want to go to the PCB capabilities. And so this is what I was talking about the design parameters. So the number of layers, FR4, maximum PCB size, 500 by 1100 millimeters. So you can make a pretty good size board. Board size, tolerance, gives you the board thickness, tolerance, plus or minus 10%. Board thickness, we don't really care too much about that. Minimum trace, that's 4 mils or 0.1 millimeter. So that's the minimum trace that they're going to allow you. So if you went under that, you'd be not a happy camper. Minimum spacing, it looks like they don't really care, unless, I guess that falls into the same thing. 0.1 millimeter for the minimum spacing. So you can plug that into Fusion 360 if it's different than their default. And when we do a design check, it'll verify that. And the size, the ounces of copper, we don't care. Drill sizes, 0.2 to 6.3 millimeter. Okay, so we're right at their very minimum, which is okay. And our holes are 4 millimeters, so we're well within that. So we're good with that. You can do the annular ring around the holes, stuff like that is 0.15 millimeter. Finished hole diameter 0.2. Everything looks pretty good. Silk screen. There should be a minimum size. Yeah, a minimum character width to height ratio 1.5. Minimum character height is 0.8. So minimum character width 0.15. So you got to make sure you fall within this spec when you put your letters on there, and then it goes on about stuff. But we should be good. We should be really good. We just got to make sure we change it to 0.2 for Fusion. All right, so there's that. All right, so now let's go to Fusion 360 and look at their design rule thing and change the drill size, and I'll show you about that. All right, here we are in Fusion 360. So we want to go to our PCB here. And now, the rules and the design rules. Okay, so this is our design rules here. So then you could compare it. See, I already changed the drill size. So we should be, everything should be good on this. Fusion 360 is a little bit, this was like 0.35, so they're a little bit conservative on it. But sometimes you have to, you're running out of space and you really have to crank down some of these tolerances to the limit. But that's the only thing that I think we'll have to do on this project here is just drill size 0.2 millimeter, and we should be good. So now we got that behind us. So we have to do a design rule check of our board. And it will make you cry sometimes because there can be a lot of errors. And you might think that you have it really nailed down good, but when you do a design rules check, it can make you cry. So we're going to do this, go back to the rules, and then check design rules, okay? So we have over here, not too bad, but I've had hundreds. But so we got 4 air wires over here, okay? So you just double click on one and it'll tell you, see this one, this trace right here is not connected completely to here. So that's an easy fix. So we go back to our design now, and you probably just want to delete this out right here, like that. And it's a little bit off, but we're going to put a trace on here. It's got to be on the bottom layer, and we're going to check that. This one is a lot easier to move around and stuff. So we're going to hit that right there. And then I'm gonna drag this. I'm gonna drag this via into shape here. Just like that. Good enough. All right, so that is that. And that's how you do that. We got some wire stubs. There's always wire stubs everywhere. I don't know what it is with Fusion 360, but it loves to give you wire stubs. So all you have to do is go in there and you have to delete the wire stub. And sometimes it's hard to get it on there. Let's see. Let's get it up here. Where are we here? Let's go to the top. It'll probably be easier to select. There we go. Right. Nope. Well, let's delete that one right here. And then we'll get to it, and then we'll just add more. It's going to flag you for that one too. So get that one while you're there, and that one too. See, that one just took one out. So we want to make sure we're connected here and here. All right, so then that's what you do. You just go knock all these out. And this is 4 here that I approved because just the way the connector is. And they don't. Fusion tolerances don't like that. But you can override it by just right here pressing approve down here at the bottom. So that's all you got to do is you got to clean these up, run the design rule check until, keep doing it over and over, and do it a couple times when you're done just to make sure, because it can find them later. And just until everything's cleared up and you don't get any more. So then you're ready to submit your PCB after that. And so we'll save our changes here, and you can do that on yours. You don't want to watch me do all of those. Okay? Okay, so I finished cleaning up those wire stubs and air wires. So everything is ready to submit to the PCB place. So we have to generate our Gerber file and our drill file. And usually you submit it in a zip file, but it does that automatically. So let's jump back over to Fusion 360 and we'll do that. All right, there's our board, and it's make sure all the errors are gone, and it's saved. And then we go to manufacturing and export Gerber NC drill assembly and drawing outputs. All right, there's your files here, and we hit OK. And now we want to select where we're going to put them. And right here. And so I have my own directories. Everybody has their own directories. And there's the I/O board. So I'm going to do a new folder, and I'm going to call it Gerber's. Alright, double click in there, set save, and save. Okay, so this is your file right here, your zip file. It's all ready to go. If you want to look in it, you can just double click, and that's what's in it. Goes down in, cam outputs, then you got your assembly, your drill files, and your Gerbers. Alright, for all your layers. Alright. Okay. Okay, so we generated our Gerber files, and we have it in our directory, and so then we just go to our website for our whoever we want to do our PCBs and submit it. So let's do that. I'll use PCB Way, and you can use whoever you want, and let's do it. Okay, let's go to PCBWay.com, and we're going to do the prototype. And we're only going to do 5 boards. I don't want 10. Oh, 5 right there. And so then we got to put our size in. So we want 63.5 by 96.5. Alright. 2 layers, everything. I'm going to go purple on this one. Everything else is good. 1 ounce, blah, 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 blah. No stencil, no assembly. Calculate. Alright, so it's 59 bucks with shipping and everything for 5 boards. And so, save to the cart. And gotta agree to that they don't, you're not making weapons and copying people and all that stuff. Alright, once you're signed in, then you add your Gerber files. And that's down in here in your folder for your project. There you go. Submit order. Okay. Now they'll look at it and review it and either reject it and tell you what you have to do, or they will ask for payment. All right, that's pretty much it. Okay, so, well, that's pretty much it for now. So we wait for our PCBs to get here. And then is what I'll do is, that's when the next video will start. And we will have to go through the bill of materials, so that maybe I'll do that. Maybe I'll do a video of that while I'm waiting for the PCBs. And we'll go through the bill of materials, and I'll order the parts. And I have some on hand, but I'll have to order some of the parts, and then we'll put it together and see if it works. And I'll see you on the next video.